Yeah, I'm inside. Arey, wait, stay no. Wait. No one joined. I joined from my thing. Wait, should I have to mute myself? Hello, everybody. We will start off in another 5 minutes. We're just waiting for more people to join us. In 5 minutes, the event will start. Thank you.
It's here it's in terms of trillions, right?
Check one. Hello, everybody. As already said, welcome to another session by Girls Code, where we are having Pragati Rai. And thank you so much for taking time off your busy schedule and joining us today, ma'am. And we are very excited for a very eventful session where we're going to learn so much for you. I'm sure about that.
Hello, everybody. I'm Ananya Vedala, a Microsoft student partner as well. And before we start off with the session, we'd like to give a small introduction about Mrs. Pragati Ogal Rai. So she's the director, developer audience at Microsoft, the secretary ISSA India chapter, along with being the author of the book Android Application Security Essentials. And in addition to all of this, she's also the winner of the 2014 Zenov Thought Leadership Award. With over 19 years of experience in technology domains like mobile security, commerce, payments, and banking, she's a passionate advocate of bringing people and technology together. From starting at a platform security engineer with Motorola uh, to now being the leading developer relations at Microsoft India, she's truly an inspiration to all of us girls here who want to learn and grow. So we're really looking forward to this amazing session, and I would now hand over this the event to Mrs. Pragati Ogaraj so that she can start off with the webinar.
Hello everyone. Hi, this is Pragati. I'm also going to share my screen if that's all right. And I will, let me just share my screen here. Oh, okay. So screen sharing is disabled. Is it possible to enable it for me, Ananya?
Yeah, give it.
Because I had some, yeah.
I'll just do that. Give me a minute.
Mm-hmm.
Yeah. Yeah, I think you can share your screen now.
Perfect. Okay, let me know when you can see it all right.
Yeah, I can see your screen now. We can see your screen.
Perfect, perfect. Okay, and uh, okay, so Ananya and Girls Code, thank you so much for inviting me today, and thank you for the gracious introduction. It's really an honor to be here with the Girls Code. I know you guys are really, you ladies are really trying hard to bring this whole community together, and I'm really appreciative of your efforts. Um, um, I have spent considerable amount of time in security and in the Android domain. So it will be a wonderful journey for me also to share Android security uh, overview with you. I've kept this talk fairly broad so that each one of us can connect with it. It is a very deep topic. So each slide in itself is like a webinar in itself. So we'll breeze through the overview of Android security. I'll touch upon different aspects of it. I will also talk about how it has evolved over the years. I started working with Android in 2007. So you can imagine Android has uh, gone through a long journey of 13 years as well, and it has evolved. So with that, let me just begin. My contact information is here. You can reach me via email or on LinkedIn. I am very approachable there. For any questions, any follow-up questions, feel free to reach out to me. Okay? So, what is the agenda for today? The agenda really is very simple. Oh, sorry. I'm going to focus on a few key points. And the first among them is, why do I really need to understand Android security, or why is it even important for me to be listening to this webinar for 1 hour? So that's the first thing that comes to mind. We are all power users of cell phones. So why is this important? The second thing that we will touch upon is the Android software stack. Now, the stack is what is the operating system or the software bundle that is on your phone. So in this, let's look at this and understand what is the structure of this Android stack, and also what are the security measures that are inbuilt into the stack itself. Next, we will touch upon permissions, and permissions is a key security artifacts that we as users also interact with, and this is a key artifact for application developers to understand as well. So if you intend to write Android applications, it's a very important thing to understand, very important concept to understand. And if you are a user, a lot of us are, Android, again, very important to understand. Next, we move on to the application components. It is more from a developer perspective. So when we create an APK file for Android, what are the different components that go in that application, and what security considerations we should keep in mind for each of the components? And last is Android application signing. It's a very interesting twist to the signing that we usually hear and think of when we talk about signing. So very important to understand that as well. Now, beyond that, there are plenty of other topics that need to be discussed for Android security, like the kernel security, network security, security of Android from enterprise perspective, plenty of other topics that can be touched upon, but let's stick to these few for this hour, and we can always come back and talk more. Okay, so I notice we have 8 people in the waiting room. Let me just admit all. Okay. 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 So coming to the next one. Okay, why should I understand Android security model? 3 main things. The first is our phones are very, very smart, right? You are all power users of the phone. And once your phone is compromised, it's not by an application, it's not just that application that is in trouble, your entire data is in trouble, right? Your Twitter accounts, your Instagram, Discord, whatever, your emails, everything is 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 compromised once one malicious application is downloaded on the app. That's one thing. The second thing is Android is a open platform, right? It is built using a lot of open source software, and I am a big proponent of open source software. So that is the reason I'm always associated with Android. But with open platform, there are 2 things. One thing is that the entire source code for the Android platform is available on GitHub, right? So anybody can look into the code, can play around with the code. And the second thing is, it is very well documented. So if I want to understand about, let's say, graphics system, right? I just need to type graphics on Android, and I will come up with tons of data, tons of articles and information that talk about the graphics applications in detail, how to hack into them, and even all the way up to the code. So it's very well documented, and and that's a good thing and a bad thing if you look from the perspective of an Apple phone, because iPhones are closed system and not much is known about them until we go and try to start hacking it ourselves. The third is only you control your phone, right? So you can install an application. So in the earlier versions of Android, when we would download an app, we would get a whole screen that says, do you want to accept all the permissions or not? Do you want to give these permissions to your application to access your contents, to access your location, etc., etc.? And you would accept it. Now, in the newer versions, you install it, but every time an application tries to access for, let's say, your location, the first time it does, it asks you, do you want to allow the application to access your location or not? And you, and only you, can say yes or no, right? A lot of times we are in such a hurry to get to what we want to, that we really do not spend time even reading what is it saying. We press okay, and boom. But that's where we really need to be careful about, because once you have given a privilege to an application, for example, to access your location, the only way you can turn it off is by going into the settings and then again revoking the permission that you have given it. So you control it, and it is really important to understand how this whole mechanism works. Yeah, so this is how the phone does, you all know. Okay, so coming next, it is the Android stack. Ananya, will you keep allowing people who are in the waiting room, or shall I do it?
I do not have access to that for now, so you'll have to do it.
Okay, so then I'll just continue admitting them all. Right, okay.
Thank you.
Okay. Moving on to the Android stack. And also, if you have any questions, you can actually just unmute yourself and ask me there, and we can quickly sort it out. Let it be a very open conversation between you and me. So wherever you have questions, just pause and ask. Okay. Okay, so moving on to the Android stack. So Now, this is what the Android stack looks like. So Android is a modern operating system, right? So the way it is layered on the phone is beautiful. You will see very distinct logical layers of software stacked on top of each other, and that is the uh, Android framework, or the code or the software that resides on the phone and your phone is bundled with, right? So this is what the framework looks like. Now this is a newer diagram of uh, okay, I'll also keep admitting, so this is a newer diagram of the Android software stack, and I am going to actually just go to the next one. Usually, this used to be the old diagram or the old way of representing the different stacks, and I kind of like it because I think it's more, it's cleaner and more crisp. I'll come back to the newer diagram or the newer representation, but let's understand the stack through this representation, because I find it very clear and interesting. So, and I'll tell you what the difference is from this version to the newer version, okay? So if you look at this, the Android is beautifully layered into different logical layers, okay? Now, let's start bottoms up. So the Android stack is built on SE Linux. So SE Linux, so Linux is like the, is a very well respected multi-user operating system. I'm sure all of you have used it. And what Android does is it uses this multi-user functionality, or the multi-user sandboxing of each user into their own process beautifully by running different apps. And this actually forms the basis of Android security. Okay, and we will talk about it in the next slide. So that is the basis. Just like, I would be sharing a Linux system with my other colleagues, I would sign in with my username, and my colleagues would be signing in with their username. Imagine the same scenario where different applications are different users, right? So application A and application B, both are using the same kernel, they are using the same resources, but they're not encroaching upon each other's private area or private data. So that is the basis of Android security. Now, on top of the Linux kernel sit the libraries. These libraries are the ones that your applications use to run, right? Like the media framework, if you're using a graphics, if you're writing a graphics application, then the OpenGL and other libraries. And alongside with this sits the Android runtime. Now, just like, for Java, when we write Java applications, we have a Java runtime environment, JRE, right? Similarly, this is the Android runtime environment. And what it does is it lets you, it actually executes your APK file. Now, it has some core libraries that help in the execution of your code. And then earlier there used to be a Dalvik virtual machine. Now it has been retired, and it is the Android runtime, right? So that is what is the Android runtime environment. So we'll come again back to the Android runtime, but let's move up a little bit. Now, above the libraries and the Android runtime sits your application framework. What is this application framework? This application framework are the SDKs that you use to write your application, right? And on top of it sit your applications like the phone, the contacts application, or even the applications that you write, right? So if I write an application, let's say a bookstore application, that will reside in the top layer. And the bookstore application, for example, will use different libraries, right? It might have a database to store books, it might have UI to enter and search for new books. So all the SDKs for that reside in the application framework. So I will use the activity manager, for example, to manage my activities. I will use the content provider to store my data, right? And then to run my bookstore application, my code will use the Android runtime environment, right? And at the end, it will run on the Linux kernel. So that is the Android software stack. I'll pause for a minute here if anybody has any questions.
Well, you're talking about that activity manager. I don't understand that. What is that activity manager does with the application things like phone, etc. About bookstore programs that you're telling about that. Can you explain a bit more?
Yes, absolutely. So, so tell me, who asked the question? Are you familiar with how the Android application is structured in terms of components?
No, I'm just a beginner. Well, I just thought to join the meeting right here.
Okay, then I will say hold on to your question for just a little longer, because we are going to talk about the components and then it will make much more sense. Okay, give me just hold on to your question for a slide or two. Okay, but if you ask me, hold on, let's just stick to your question for 2-3 slides. Okay, so this is what the stack looks like. Okay, now any other question I can answer here? I'll move on to the next slide. Okay. Okay, I'll move on to the next slide, and I have one question that I have to answer later on. Okay. Okay. So let's say, so this, I just took a screenshot. I typed PS minus EF, and this screen shows up. Now, what I want to show here, so the first one that you see, you know, app 55, app and the others, this is the user ID of an application. So you will see that different applications have different UIDs. So there's an app 8, there's an app 64, right? So now we will okay, so each application is given a unique UID and a group ID. Okay, and this happens at the install time. So this is what I wanted to show. Now, can application 8 and application 64 talk to each other? The answer is yes. Two applications within an Android application can each other, but they should have proper permissions to application. Okay, so that's what I wanted to say here. Here, I'm just typing and just see what the Android runtime environment. Now, Android runtime, remember about the Dalvik virtual machine and runtime. Now, let's say you, if you are an can actually execute a jar file, for example, on Android. So the answer is no, because what happens is the Android, given that it is a mobile phone, it actually converts the bytecode, which is the jar file, into smaller codes which are read by the register, because the Android runtime is a register architecture, right? Just for faster execution and faster compilation of the applications. So that is the Android runtime environment. Now, important to understand and very key distinction. Remember how the Java runtime environment has a garbage collector, it has a security manager and others. Well, Android runtime environment doesn't have any of those. Okay, so it's important to understand that application runtime environment is not a security boundary, and there are no permissions that are enforced in the virtual machine. Every security is either in the permissions, which is in the application piece, or in the Linux kernel. So very important to understand that. Also important to note is there's no distinction if a Java application is running or a native application is running. When I say native, sometimes it is a requirement that we have to write a code in C or C++, which is also supported by Android. So those are the native applications. So that's the point I wanted to make here.
That's a native.
Why did I have to put in the binder component framework here? So if you look at the Android application structure, right? Think of it as, let's take an analogy, right? Think of it as a family, right? Where there are kids, there are grandparents, there are parents. It's a whole group of people, right? Each of them has their own strengths and own action and individual and an individual identity. Similarly, in an application in Android, there are different components, right? There is an activity component, there is a service component, there is a component for content providers, a component for listening to broadcasts. So this framework that Android has used actually is called the binder component framework, and it used to be used earlier in different applications, and Android has beautifully adopted this framework to organize the Android applications. So if you look at an Android application, there's nothing like a main. So in a Java, when we run Java applications, there's a main, right? That is the first point of entry into the application. Android doesn't have that, right? So there will be different components, and when you click on an application, whatever frame comes up first is your entry, or is the first thing that opens up. And based on, so let's say when you click on an application, the login page comes up. So you log in, and then you press, you enter your username, you enter your, and say sign in, right? So then the sign in activity. If instead you would have said forgot my password, so then the forgot my password activity or the component would have opened up. So that is a difference. Based on what a user clicks on, that thing happens. And how do these components interact? They interact either through intents, right? So if I want to, and we'll come also later. So intents for Android. On top of it was the application framework and the application layer. So the application level, it is the permissions that ensure the security of the Android system. So let's say there is an application A and there's an application B, right? And there are different components or different family members in application A. And then there are different family members in application B. Now, the components should have proper permissions to talk to components of the other application. So that, and those, there are different types of permissions that they need to have, which we will talk about, to make that interaction happen, okay? Now, somebody asked about the activity manager here, right? So what will the activity manager do? Remember how when we write the Java applications, we also say we have those include libraries, and there are SDKs that we use, like the Java SDKs. That is what the application framework have. Okay, so the activity manager, what does the activity manager do? Activity manager makes sure your activity runs properly. It also makes sure that you have the right permissions so that somebody that you can call somebody, and you also have the right, and you're exposing yourself properly. So if other activity wants to call you, they can find you. So all of that work is done by the activity manager. As an application developer for an Android application, we really do not need to care about it, because the activity manager will make sure that whatever permissions you have declared in the manifest file get implemented and executed. So that's the role of an activity manager. Similarly, to an activity manager, you will have a service manager, you will have a content provider manager, each referring to or managing different components of an application.
Well, that seems to be very clear about. You were talking about that Java code and native languages. Can you explain me more about that native things that helps in developing Android applications?
Absolutely. So see, sometimes what happens is, so Java, if you know, like Java and C, both the languages have different characteristics, right? So when you write an application in C or C++, you have more control on the underlying hardware, and also you have access to some components that are not available in Java, right? So let's say you want to access a hardware accelerator. Let's say a hardware accelerator. Okay, so that is something that you would like to do with a C code. So what you can do is, in a Java file or in your application, what you usually write in Java, you can embed C code or a C++ code. So that piece, right, the C and C++ code that you have embedded is called the native code.
So, is there any library that exists for embedding the code inside the Java?
Absolutely, they're called the ND.
Okay.
Okay.
Yep.
Okay.
Thank you.
Is that Pavan I am speaking to?
Yeah, that's the one you were speaking to.
Okay. Okay, next move, let's move on to the permissions. Very, very important. Okay, so permissions. So, you know, if I just go back components. Now, you see that components may or may not talk to each other based on the permissions you have. So permissions are critical in the way how an application runs. Now, all permissions are not same, okay? There are some permissions, for example, let's say change background color. And then there are some permissions like shut down or break your phone, or, you know, access your SMS messages. So all of these permissions have different protection levels. So there are 4 protection levels in the Android system. The first one is the normal protection level. Now, the normal protection level, these are permissions, and each of the activity, right? Each of the activity or the component of an application will have their own set of permissions. So again, going back to, let's say, a bookstore application where the first is like, you know, login page. So that activity which manages this login page will have its own set of permissions. And then when you sign in, another activity opens up or a UI page opens up. That will have its own permissions, right? So different things different components will have their own permissions. Now you will be retrieving some data from the database. That content provider will have its own permissions, and each permission, the levels are different. The first level, or called the level 0, is the normal permissions. Now these permissions, even if you like install an application and you run it, usually what happens is, no, you won't get that dialog box which says, do you want to grant this application this particular privilege, right? So Android.permission.vibrate or set alarm. Now these permissions may cause you some annoyance if somebody meddles with it, but they won't cost you money and they will not compromise PII. So that is how they are defined. So that is that is permission level 0 or normal permission. Okay. The next level is a dangerous permission, and as the name sounds, right, it's dangerous. So they will cost you money. They can leak PII, things like, send SMS, call phone, access my location. All of these are the dangerous permissions, and it is a very extensive list. Um, the, it's a exhaustive list, okay, and you can find all the permissions under, if you go to source.android.com. I've written that the reference in the last slide as well, so you can find all the list of the entire permission set there. So that's the dangerous permission. And whenever an application that you have installed on the app tries to access your location, you will get a dialog box. Application wants to access your location. Do you agree? Do you not agree? And you have to say agreed or not agreed. Right? So those are dangerous permissions. Then the third type of permission protection level is the signature. Okay, that is level normal is 0, dangerous is 1, signature is 2. Now, what is signature? It's a very, very interesting permission. So what happens, let's say I'm a application developer, right? And I develop an application, let's say bookstore, that's application A. Now I will sign all the applications that are installed on the Android platform have to be self-signed if it is a version 1. So I self-sign it and I install it on my phone. Now I create another application B, and I also sign it with the same application, with the same signature, and install it. So now, since both the applications A and B are my applications, they can share some data with each other. And those kind of permissions are called the signature permissions, because both the applications are signed by my certificate. Now, this is very interesting because you can use it for different scenarios. Now, and these signatures, these permissions are very powerful. So for example, if my application A can actually inject some events in application B. Now, and for example, if it is remember, so I'll give you examples, right? And next time when you do see some applications from the same author or the same company, you can see how one application can lead to another application, right? So so they can inject events, like they can inject key press. They also have some signature applications like shutdown. They can cause one application to application A can cause application B to shut down, right? So those very powerful applications, because both the applications are written by the same author, they are trusted. Then the fourth kind of protection level is signature or system. It is not in most cases. It is in most cases not available to the developers. It is especially for the OEMs or the phone manufacturers when they want to upgrade something. So basically what happens is the application should have the same signature and that the other application have, and should have the same signature as the system. So the entire, remember we looked at this picture of the Android stack, the entire stack is signed by a signature, right? A certificate. So this application should have, if you want to call something like access USB or set time, to make changes to the OS itself. So that application should have the system or signature permission.
You were talking about signature. Means what signature do? Does that enforce any security permissions or things so?
Okay, Pawan, I'm going to ask you to wait for that, because application signing in Android is very different from when we think of signature. So give me a couple more slides and I come back to your question. But yeah,
Okay.
that's why just hold on to your question a little bit longer. Okay. So any other question? Otherwise, I'll just move on to the next thing. Okay, cool. Now, although Android has an extensive set of permissions, you will not need to define any of your own permissions. But let's say I need to, because I have two applications, A and B, and I really want them to do something really funky or something really different. And I want to design a whole different thing. So I can actually create my own permissions as well. Now here I've created it access details, and I've given it a label, description, and I've put it under a group. So I can create a permission group. And well, actually this is Android.permission group cost money. It already exists. So I've added it to that permission group. But this is my own permission that I have created. Now coming to application components, remember the binder framework where we said each application in Android is a big happy family. So that's what this is about. So an Android application is made up of different members. It is made up of activities, which are, if you, in the easiest way, these are the screens or the UIs. Then there are the services. What are services? Services are background processes. So activity would be like, the UI part where you enter the username and ID and your password. A service could be like, the music player that runs in the background when you are playing a game. You don't need to actually understand anything or do anything about it. Whenever you click start game, the service is automatically triggered. So that is the service component. The third is a broadcast receiver, really a mailbox where so applications can register to receive broadcast events. So let's say, let's say we restart the phone, right? Now, once you restart the phone, and in my application, for example, I have it, whenever the phone restarts, change the background color of my application, okay? Or whenever the phone restarts, increase a counter by 1, something like that. So what I can do is I can create an intent that whenever the phone reboots, I get a mailbox, in my mailbox a message, phone rebooted. So I have to register to receive this broadcast signal. Now activities and services, everybody sends out broadcasts, and it is up to you to listen to it or not listen to it. So that's the broadcast receiver. Then there is this content provider. It is basically the database. And you use this content provider to actually communicate with the database. Now, there are other components also besides the 4 major ones. They are fragments, layouts, resources like the pictures and others. And the really most important, the heart and soul of an Android application, which is the manifest file. All components are secured with permission. To access an activity, you need to have write permissions. Right? To access a service, you need to have write permissions. And what are the permissions? And there could be some services, for example, the music player of your applications, you really do not want to expose it to other applications. So you can even hide it, right? You do not want to expose it to the rest of the Android world. So it's up to you to decide what the visibility of a component is. So I've given some details about it here. You can read it. I've just listed it out. So this is the activity. They run in their own UID, and you communicate to an activity using an intent. Now, again, service, you start with an intent. You can read it yourself. It's just more details about each of the components. Okay, let's come to the intents, because that's very interesting. So the components talk to each other using intents. And intents, as the name suggests, is I have an intent to talk to you. And that's what an intent is. Now, does the other person want to talk to you or not? It is their discretion, right? The other thing is intents are always asynchronous, which means that you fire off an intent and then it's up to the other activity to listen to it or not take any action or do whatever they want to do with it. Just leave it, right? So they're asynchronous, and it's up to a component to listen to it or not listen to it, and then they are absolutely not secure. Okay, so I can say, this is my username, this is my password. Now I want, whenever I say sign in, I press the button sign in. Now I want the activity to the activity which actually does the signing in and says, yeah, login successful. Now, if I pass in my password and my username in the intent, then what happens is anybody can snoop into it. Okay, and not just snoop into it, they can even change it. So intents goes to everybody. They're absolutely not secure. So please do not put any sensitive information if you are using intents. Okay, and components need not be in the same application. You can have an intent to listen to an activity of some other application as well. So those are some characteristics of intents. Now, an intent can be explicit or implicit. Explicit means I know the activity, I know the component I want to talk to, and I only want to talk to that particular component. So you send an explicit intent to talk to a particular activity. Then there could be implicit intent. Okay, I have logged in, let the whole world know about it. That's an implicit intent, and anybody who wants to listen to that intent can listen in. Okay, so that's the implicit intent. So I've been saying all along, right? You fire an intent to talk to another activity, and if the activity wants to listen to it, they will. Or if a service or a component wants to listen to it, they will. Now, how will the other activity say, yeah, I'm listening to your intent? That is done using intent filters. So in the manifest file, which we will come on next, which is the heart and soul of the Android application, you have to say, using an intent filter, what is it that you want to listen to? So here, for example, you want to say, this particular receiver, the broadcast receiver, is listening to an intent called boot complete. Okay, so using intent filters, you decide what you want to listen to. The only thing is, if you say, I'm listening to this particular intent. So for example, in the example that we have here, the receiver has said, I'm listening to the boot complete intent. What it does is it makes the receiver exported, which means that you can't hide it anymore. It is available to be seen by anybody or all the applications in the Android system. So that's the only thing to be mindful of with the intent filters. And then a very beautiful kind of intent called the pending intent. So let me explain to you what a pending intent is from using a use case. So when, let's say, there are two applications, application A and application B. Now your application A says, I have an intent to run an activity in application B, right? So what happens is that activity in application B runs as if it was part of application A. So it runs in the same process sandbox. It has the same privileges as if it was part of application A. With pending intent, what you do is you say, okay, I want to run this activity from application B, and by the way, I'm going to sleep. Whenever you are done, just let me know, kind of a situation, right? So what happens is you fire a pending intent. So the application A fires a pending intent to run a component in application B, and then that component in application B runs inside the process sandbox of application B and not A, because because application A actually has gone to sleep anyways. And whenever the activity completes, the result is passed on to the component, calling component of intent of application A. So that's a pending intent. Okay, now coming to the heart and soul of the Android application, the Android manifest file. What is an Android manifest file? It is an XML file, so you see all the application XML tags here, and it basically is the policy file for your application. It declares everything, right? It talks about what is the version against which you built it, right? It talks about the SDK level against which you built in, okay? It talks about all the components that you have in the application, all the activities, all the receivers, all the content providers, everything needs to be listed here. And along with that, all the permissions associated with each component need to be listed here also, right? So this is the Android manifest file. And the more time, if you're an application developer for Android, the more time you spend on it, looking into it, and the better it will be and the more secure your application will be. So that's the Android manifest file.
Is it something like declarations of the things?
Yeah, declaration of everything. So if you look at this Android application file, so there is this activity, right, called friend tracker control, right? And then it has an intent filter. So it is listening to two intents, main and launcher. So just like that, everything needs to be listed, whatever. And if you have something which is not in the Android manifest file, either your application will not even compile, because that thing doesn't really matter. For everything, the compiler will come back to the Android manifest file. So it's a policy file. Okay, so what it does everything. It has access rules, it has dependencies, libraries, SDKs that you are adding, all the definition of all components with all the permissions that they need. Are they exported? Are they not exported? If you define any new permissions, they need to be here as well. Everything needs to be in the Android manifest file. Okay, I just wanted to put the external storage here for one important reason. So remember I told you that all the applications run in their own process sandbox. So it's not feasible for, or it's not allowed for one application to encroach on the private files or private data of the other application. But you know what? The external storage doesn't come under the preview of the OS. So VFAT does not support Linux access control. So you have to be careful when you are storing files in an external storage, because they are outside of your phone, and the Linux access control doesn't reside here. That's the only reason I wanted to put it here. And therefore, if you are putting anything which is a PII or which you mind sharing, that needs to be encrypted. Okay, Pawan, coming to your question around application signature. So when we talk about signature, really, the main reason we sign something, and in most cases, when we talk about signing, it's usually using a certificate authority. We sign it because we want to say that it is, it is to prove integrity, that this application or this, if this is signed by a CA, by a certificate authority, and it is good. So the certificate authority vouches for the trust or for the authenticity of that piece of code. But in Android, the signature is used for a different purpose. The signature is used to make sure to identify who the author is. So all you can sign, you don't really need a CA, certificate authority, to sign your APKs. You can self-sign it. I can create an application, I can sign it myself, and I can push it on the phone. There is nobody telling me not to do that, right? So it defines in Android, signature or signing is used to identify the author. Okay, so when I sign it myself, it identifies that application with Pragati. That is what it is used for. And so remember the case when we had that signature permission, where two applications signed by the same author can exchange data or use maybe the same data store? Because both those applications are signed by me. The signature denotes that the authorship, who is the author of that application. So that is what the Android signature is used for. The other thing that the signature does is when you upgrade an application. So let's say I have my application bookstore installed on the app. Now I have, as a user has agreed to do automatic updates or upgrades. Only if the newer application is signed by the same signature will it auto upgrade, otherwise it will not. So that is the whole rationale behind signing an application in Android system. Now so you can also actually, they have also improved on the signature part. So you can, they have, for example, in version V2 of signing, they have added hashing and checksums. So they have also evolved the signature to make sure that to do the integrity checks, but just by jar signing, you're good to go. So that's the whole purpose of signing an application in Android.
Yeah.
Okay?
Yep.
Okay. And yeah, so like I said, they need two applications, they need to have the same author or same signature to be able to auto upgrade. And also when you auto upgrade, right, in older versions, you could not have added an extra permission. So for example, if the application that is currently installed on my phone, let's say, doesn't even have access location signature, access location permission. But if I install a new application or upgrade, whenever this application launches and tries to use the location, I will be prompted. Okay, so that's thing. And location is preserved. So whatever UID was there, you will continue with the same UID because it's essentially the same application, just with some additions. Okay, so then the system packages like the clock or the calculator that come bundled with your Android kernel, those are the system packages. They have the system or signature or system permission, because whenever they say fresh installs available for your phone, that is when all those applications are upgraded. So I've worked in an OEM. I used to work for Motorola, and I know how things work. So let's say you have a Samsung phone, for example, right? Now, and the Samsung phone is flashed with a Android operating system. So what happens is Samsung will add some of its own applications and some of its own features to the basic or the vanilla Android OS, right? And those will be some extra applications, and of course, and so those applications are actually signed by, have permissions like signature or system. So whenever Samsung sends a request, upgrades are available to your phone, then what happens is those applications are able to upgrade because they have signature or system permission.
Same signature.
Okay, so just to summarize, we have touched on just a few topics here. Most important, just like a multi-user environment in Linux, all applications run in their own sandbox. Application A doesn't have a right or doesn't have access to application B's data until and unless you leave holes in your application or you do not define the manifest file correctly, or if you have made sure that you're listening to some intents. Okay. Now, the other thing is all applications need to be signed just to make sure who is signing it. And this is also a very interesting perspective, right? Every application is signed by the author. So if you write a buggy application, you know, your reputation or my reputation as an application developer is at stake. So be very careful with the Android manifest file, because that's the place where you will define all these things. Okay. And I'm only quoting two references here, developer.android.com, source.android.com. You can get almost all information here. You know, all the, you can have access to the entire code, Android code, and you can actually go in and play around with the code, go deeper and understand how each and every component is laid out. And if you even want to extend the Android operating system, you can submit pull requests there. So those are the two references, and I think that they are more than they suffice really. And then this is my information. Feel free to reach out to me if there's anything you want to discuss about Android security, about other technologies. I'm very open to that. Okay, any questions? I'll stop.
Yes, I'm having. Hello.
Yes, Sarthak.
Yes. What do you prefer, native app development or developing app flows single code based like using Flutter SDKs or React Native?
Yeah, I mean, you know, Sarthak, this is interesting because when I started writing mobile applications long time ago, 2010, since then we have had this question: what do you prefer? What should we write an application in? And it is really, I will say, based on your use case. If I'm writing a gaming application, I have to go native. There are no two ways about it. If I'm writing an application where it is okay, where it is 1 second, what is 1 second? 1 millisecond delay is okay, or a 2 millisecond delay is okay, and then it's okay. I can go either ways. But if you're writing mission critical applications, if you're writing gaming applications, you absolutely have to go native. That's my take.
Because efficiency matters right there. Was it audible?
Yes.
Well,
Hello, any other questions?
well, not.
Okay.
Just one question. You mentioned some sources regarding developer.android.com. Is that suitable for beginners?
It's for everybody. I also refer to them because they keep, yeah, they are for beginners to advanced to everybody. Very exhaustive. If I have to get started, I will go to developer.android.com. If I, like even today, I went to source.android.com just to check, were there any changes in the latest APKs? So it's, as an Android developer, you know, I will always have these two tabs open. It's for all levels.
Okay.
Okay, I'll stop sharing now.
Please tell what are the most trending languages, programming languages or technologies in trend?
I didn't get the question. Is it Ankur?
No, it is not that. I just want to ask, what are the
Uh-huh.
most trending programming languages or technologies
Yeah.
are
Okay. Yeah, I'll tell you two things. Well, I'll give you two data points. First, I'll tell you what are the ones that are actually, you know, not the latest and the greatest or the upcoming ones. but the ones that have the most people programming. So the top is Python, followed by JavaScript. So these are the two top languages that we have, that people are coding in the world today. So Python is number one, and JavaScript is number two. Now, what are the upcoming languages? Plenty, and everybody has their bets on them. Go is something that everybody finds is going to be most interesting. So that's one. And then you name a few. What are you hearing? What are some languages that you are hearing? Because I'll tell you what I'm hearing.
Obviously, JavaScript and
Yeah,
Python.
JavaScript and Python are here to stay, because see, all AI applications are written in Python, right? So that's here to stay. It's not going anywhere. Yeah.
Could you tell me more about the React Native? Is it worth programming for Android applications?
React Native. I
Yeah.
haven't coded in React Native for Android. For Android, I've typically used only Java and and C Sharp and C. Only if you want to go cross platforms would you go with the React Native, right? I have no views on that really, because I haven't done much on that.
Okay.
I noticed some questions in the chat also. Could you share some resources to build your own custom ROM? Custom ROM in AOSP. Okay, perfect. Well, resources, and so I used to play a lot with the operating systems, and I would just follow the instructions on GitHub. If you go to their GitHub repository, there will be a way. They will have how to compile it and how to build it, and then how to flash it on the phone. I'm not sure if they have it how to flash it on the phone, but they have all those details there. I can't hear. Okay, that was me. And then anything? Okay, okay. Any other questions? Otherwise, you're good to go.
There were a few questions when we had like given out the registration form. So I thought I just wanted to know if you could answer those. So one of them was how to get started with product evangelism.
Product evangelism. Okay, cool. So there are actually, when you talk about evangelism, there are two kinds of evangelism. One is the product evangelism, and then there's the technology evangelism. So if you look at my title, I'm called the product marketing and developer product marketing. Yeah, so I do Asia product marketing. So what is an evangelist? Evangelist is just a person who preaches things, right? So they have these Christian evangelists, and different religions have their own evangelists. And I say that because the first time I told somebody I'm an evangelist way back in 2010, the person asked which religion. And I said the religion of technology. So evangelist is just a person who preaches something. So if you're a product evangelist, you're talking about a product. If I'm an Azure evangelist, I'm actually going to developers and to everybody, really talking about why Azure is the best platform in the whole big world and what are the features and others. Then there are technology evangelists. I consider myself as a technology evangelist. Now, if I'm an Android or let's say security evangelist, I'm going to talk about a domain security or a mobile security evangelist. I'll talk about technologies in mobile and security because I love that domain. And this will be product agnostic. So I'll talk about security in Android. I'll talk about security in iPhone, and I will have my opinion saying, I like Android for this, I do not like Android for this, I like iPhone for this, but I really hate this feature on iPhone. So those are technology evangelists. Now, to start a career in product evangelism, you really have to know that product inside out. That's the thing for product evangelism. for technology evangelism, you really have to know that technology inside out, or not inside out really. You need to have working knowledge of that technology. You should have the passion to learn every day, because technology changes every day. Like I told you, right, I went to source.android.com today, and just to make sure that I'm on top of things, I don't miss anything. So a technology evangelist really has to be on top of technology. And also, because you're talking to people and you are telling them and talking to them about technology, you have to have a good understanding of technology. You have to have a good understanding of uh, where the market is going with this technology. So if I'm a React Native evangelist, for example, and I have no idea, right now I have no idea about it much, I should know, is this the trending language, where it will be in the next few years? And if I should have an opinion, because I want to be telling the rest of the people where this technology can take us, or what are the use cases where this technology could be most fruitful. So those are the two evangelism domains, and that is what you need to be a good evangelist in either of them. And to get started really is to actually talk to other people and help them learn, because people will only listen to an evangelist if they trust an evangelist and they believe in the evangelist. And the only reason they will trust and believe in a budding evangelist, if they feel that this person can help them solve their problems. So that is the whole crux of this profession.
Yeah, I think that answered the question really well.
Okay, so like we said, thank you so much, ma'am, for joining us at Girls Code. And I would like to end this off by asking one question that all of us would really want your insight upon, is what advice that you want to give girls in terms of choosing career, prioritizing things, and how to move forward with it.
Okay, first and foremost, let's just get this distinction of girls and boys out of this question. Okay, it's for
I
everybody.
was
And
talking about it.
uh, uh, Pavan, were you saying something? Okay.
I was just talking about that girls and boys. I was about to say, and you said it.
Yeah, let's just get that thing out, because I think we are at this time beyond that question of boys and girls. I think it's for anybody, and even for me at any stage and any level. I would only say this: do something that you really want to do, and do something that will give you peace. Now, uh, and will make you happy. Now, a lot of times, and I have been in this situation, I've had a 20-year career. So I've had different roles and responsibilities in the last 20 years, right? There were roles where and jobs that I did that gave me really good money because I needed it that time. But I was like, going to office every day was such a chore. I did not enjoy it. I did not enjoy doing it, but I had to do it because, hey, I'm a professional, I need to get doing it. But the thing is, those things are like short lived, and they don't continue, they fall away as soon as I had an opportunity to move on to other things. So the only thing I would say is, we have to do these little things sometimes just because situation demands, but at the end of the day, do what will give you peace and happiness, because you will be able to hold on to it. Otherwise, the first opportunity you get, you will ditch it and move on to something else. So it's basically just a waste of time. So yeah, hold on to what you enjoy and you like to do. The other thing, very very important, is, and especially relevant in today's world, is, you know um, let the world know what you are doing. Now look around you. There are so many people who are doing the same thing. There are so many people who are engineers or are studying engineering, right? I find it every day to stay relevant. I find it difficult to stay relevant, right? So if you're taking up a profession, whatever profession, you have to stay relevant in that. So you have to have that passion that, hey, if something new comes up, I need to upgrade myself, I need to learn, and I need to let the whole world know that this is what I do and this is what I do really well. Now, the question is, how do you let the whole world know that you are very good at this and you're passionate about this and you really want to do this? You do that by blogging about it, by contributing to open source, by actually learning more about a particular technology or whatever interests you, and becoming that influencer or becoming that person that other people look up to for guidance and for advice. So that's how you let people know who you are and what you're passionate about.
That's really nice. We have another question on the chat. So the question says, what role would be the most feasible for a fresher to get into developer relations?
Okay, that is Manbir Singh. I think I've met Manbir. You are a MSP, right, Manbir? I think so.
Yes, ma'am.
Yeah. Okay. So,
We met at the MSP
yes,
India Summit.
there you are. Yes, I remember you. Okay, Manbir, nice to see you again. Now, so what would be a good uh, role for somebody who wants to get into developer relations? Okay, so developer relations have different kinds of roles, right? And you, Manbir, of all the people, have and met all these people, right? So, for example, you met Abhishek, who is an evangelist. So he talks about Kubernetes and Docker. So he is a evangelist. So that's one role that we have in developer relations. Then we have some people like Arco, who are program managers. So he looks after, after startup programs, or uh, after student programs. So how can we get the students engaged? These are program managers, right? Then there are marketing folks who market these events. So you had that big MSP summit, right? There were marketing people involved who actually made that thing happen. So those are marketing people who are there. Then there are community managers and developer relations, people who are always listening into social media and listening what other people are saying, getting a pulse of them, answering their questions, making conversations with them. Those are community managers. So that's another role, right? And then as you grow up, like what do? I make sure that the whole group works together as an entity, right? Then there are people who actually build content. So there are evangelists, and there are also people who blog and write about it. So there are different roles in developer relations. Now you have to pick a role that resonates with you. And so Manbir, it's actually up to you to understand what is it that the skills that you bring in and what will fit you. So these are a few roles that we have in developer relations. And
Okay, what if I don't want to limit myself on how I contribute? Like I want to write blogs, I want to publish tutorials and all,
perfect.
interact
And
with the
that's
community.
what a lot of us, yeah, and that's what a lot of us do, right? So you met Vivek also, right? So Vivek is basically a a marketing manager, right? But he also talks to people and he gave a talk on DevOps, right? So he talks about that. So he's an evangelist. He writes blogs as well. He's very much on the social things also. So a lot of us actually do plenty of things. Like my role of talking to you about Android security, that's an evangelism role that I'm doing at this part. Now, if you reach out to me on LinkedIn, you reach out to me on Twitter, and I responding, that's the community manager piece I'll be doing. So if you get into DevRel, of course, you will be doing all of that, right? But if you want to make sure, if you like, I am very good at connecting people together and bringing them together, I'd say, you know what? focus on being a community manager, something like Paras, Kundin, and then, of course, because you're a technologist, bring in that technology flavor there, right? So, but here is what I will say, because you guys are all just starting, just do what you want to do, and you will get into developer relations, and then once you have more experience, you'll figure it out what will work best for you.
Awesome. Thank you. You really inspire me a lot.
Thanks, Manbir. Any other questions?
I think we don't have any more questions, but thank you so much for this extremely insightful session. I'm really looking forward to like hearing from you again. Thank you so much for taking out time out of your busy schedule to make this happen.
Ananya, thank you so much. And I know we had a change of topic in the last moment,
Yeah.
because I really want to give a very broad talk again. So thanks for accommodating, and Rita and the entire Girls Code team, thank you so much for having me here. It's an absolute pleasure. Thank you, and have a good weekend. Bye-bye.
Thank you.
Thank you.
You too.